Alright, so the third video on solving differential equations using separation of variables. And this will be my third example. You can check out the other two videos on this. So just like I said in the first two videos, we want to be able to write our differential equation in one of these two forms. Basically, we want to be able to get the x terms with the dx and the y terms with the dy. Okay, you can see we can move the dx up here, and that would be mx dx, and the ny up here, that would be ny dy. Okay, alright, so let's go ahead and take a look at this third example. Alright, so let's see, what can I do here? Well, I can multiply both sides by 1 over y. That'll get rid of the y here. Okay, and so that's going to give me x squared plus 4 over y times dy dx, and that equals x. Alright, and then I can multiply both sides by 1 over x squared plus 4. Okay, that'll get rid of the x squared plus 4 over here and put it over here. So that's going to give me 1 over y times dy dx equals x over x squared plus 4. Okay, and then I would need to do what? Multiply both sides by dx. Okay, and so that would give me 1 over y. That would give me 1 over y dy equals x over x squared plus 4 times dx. See, the dx is over here, cancel. And there we go. I was able to get all the y's with the dy and all the x's with the dx. Okay. So now what we need to do is we can integrate both sides. Alright. So if you remember your integration rules, we have 1 over y, so we integrate the 1 over y. That's going to leave us with what? Natural log absolute value of y. Okay, and that is going to equal, now on this one, well, we're going to have to use u substitution, aren't we? Alright, so let's just come over here to the side and do that. So I have x over x squared plus 4 dx. So I'm going to let u equal x squared plus 4, so du is equal to 2x dx. Alright, so the x squared plus 4, I'll replace that with u, and then here I have x dx, but I need 2x dx to be able to plug in the du. So I need to put a 2 there, and remember, if you multiply by 2, you'll need to come out here and multiply by 1/2. Okay, and so now you can see that I would have 1/2, and then the 2x dx, that's just du over, and then the x squared plus 4 is u. Okay, so that's going to give me 1/2 natural log absolute value of u, which would be, which would be 1/2 natural log and then x squared plus 4. Now notice we have the absolute value, and we put the absolute value because we can't take the natural log of a negative number. Okay, so, and see over here, y could be negative, we don't know. But over here, I don't need to put absolute value. I can just put this in parentheses. And why would that be? Well, that's because you see the x squared plus 4? That's never going to be negative. It doesn't matter what number you plug in for x, this term's going to always be positive because we're squaring it, and then by adding the 4, it's just always going to be positive. So we don't need the absolute value over here. Okay? Alright, and so that's going to give us 1/2 natural log x squared plus 4. Alright, I'm going to go ahead and erase this, give me some more room. Alright, and then plus c. Okay, now if you watch my other two videos, you know why I didn't add the c over here and I just added the c over here, but I'm actually going to call this c1, okay, because we may have to rewrite this constant term. Okay, this is just an arbitrary constant. And just in case you didn't watch the first two videos, let me just go over that. Why we're not adding the constant over here and we're adding it over here. Okay, so I'll do that real quick. So, you know, normally we would have plus c when you integrate, and then plus a constant over here. We'll just call that d. Okay, these are just two arbitrary constants. If I subtract the c to both sides, I get d minus c. So if I have an arbitrary constant minus another arbitrary constant, well, that's just going to give me another arbitrary constant, and we just call it c1. Okay, and so you can see that we wouldn't have the plus c over here, and then the d minus c, well, that's just the arbitrary constant c1. Okay, alright, so now let's look at this. Well, we have natural logs in here. Well, we don't want natural logs. We want to solve this thing here for y. Alright, so how am I going to do that? Well, the way I'll do that is I can take both of these, both sides of the equation, and I can write e raised to this, e raised to this. See, this whole thing here is my exponent, and this whole thing here is my exponent on e. Okay, well, we know that e raised to the natural log of absolute value of y, you remember your logarithmic properties? Well, what's this? Remember, natural log is log base e, and when this e and this base on the log are the same, your answer is just what you're taking the log of. So that's just absolute value of y equals, now let's take a look at this. I need to rewrite this a little bit, so I'm going to take this 1/2. Okay, remember this 1/2, we can bring it back into the exponent, so that's going to give me x squared plus 4 raised to the 1/2. So that's going to give me e raised to the natural log, and that's going to be x squared plus 4 to the 1/2, or what? The square root of x squared plus 4. Okay, remember, to the 1/2 power is a square root, plus c1. Okay, now let's take a look at this. Now if you remember your exponent properties, that a to the x times a to the y is equal to a to the x plus y. Okay, so you can see you see this x plus y, this right here is like that x plus the y. So I'm going to rewrite it like this. So that's going to give me absolute value y equals e to the natural log square root of x squared plus 4 times e to the c1. Okay, so that's absolute value of y is equal, and I'm going to just, in this next step, I'm just going to rewrite my constant term first. So that's e to the c1 times, and then what is this? Well, this base here, okay, you see this base? That's log base e. Natural log is log base e. And since the base of the log and this are the same, my answer is what I'm taking the log of. Alright, now we're solving for y. So I've got absolute value of y is equal e to the c1 times square root of x squared plus 4. Okay, well, remember, absolute value, this thing here can be positive or it could be negative. Okay, so y would be equal to plus or minus e to the c1 times the square root of x squared plus 4. Okay, because see, if I take the positive part and I plug it in here, well, the absolute value is going to be positive. And if I take the negative part, and if it's negative and I plug it in there and take the absolute value, well, that's going to be positive also. So that's where we get y is equal to plus or minus e to the c1 times square root of x squared plus 4. Alright, so now look at our constant term here. You see this? Okay, it looks weird, but this is just an arbitrary constant. This whole thing is. Okay, we don't know what it is. This plus or minus e to the c1 is just an arbitrary constant. See, whatever c1 is, it's just a number, and e raised to some number gives us another number. Whether it's plus or minus, I mean, we don't know. So we'll come over here and we're going to say let c equal plus or minus e to the c1. And so this will be replaced with c. And so I get y equals c times the square root of x squared plus 4. And this would be your general solution. Okay, and yeah, there are, we can find out what c is, but in order to do that, we would have to have conditions. So basically, what they would do is in the problem, they would, for instance, they would give you the problem, and then they would maybe say something like y of 0 equals 1, and so you could take this and plug the 0 in for x and the 1 in for y. See, if they gave us the condition y of 0 equals 1, well, all we would do there is we would say, okay, well, y is 1, so we would plug the 1 in here, equals c times the square root, and then the 0 gets plugged in for x. Okay, and so that would give us 1 equals c times, and then that's the square root of 4, so that would be 2, and so that would tell us that c is equal to 1/2. Okay, and so this would be your particular solution. You would say y is equal to 1/2 square root of x squared plus 4. Okay, this would be your solution to the differential equation going through a specific point. Okay, see, basically what we're doing is we're getting a whole family of solutions here, whatever c1 is, I mean whatever c is. See, if c is 1, that gives you a solution. If c is 2, then that gives you another solution. Okay, but when they give you a condition here like this, they're saying, okay, we want the solution to the differential equation that's going through this particular point here. Okay, and y of 0 equals 1, that's basically going through the point 0, 1. Okay, so this right here is your general solution, and this would be your particular solution. Okay, so I hope this video's helped. If you like it, you can check out my other videos. Alright, thanks.